classes that it is a type of motion that deals with body moving under the gravity. Now, it is also called motion under gravity. So we can write. Now, a free-form motion is a motion of a body, moving freely under Earth's gravity, which is symbolized by G. Now, the gravity is called free-form motion because under the free fall of acceleration is always taken to be in the direction of downward. For example, what I'm saying is that acceleration of a body, which is a vector quantity, is always taken to be G whenever we're talking about free-form motion, which is always acting in the direction of what? Downward direction. We can consider a body that is on ground, or we can consider the ground, and a body is thrown from Earth down to the ground. From here, the consideration of the motion of the weight of the body is actually acting downward. The body is accelerating downward. So if we consider the direction of G downward to be positive in this case, what we are saying is that the body is accelerating downward. The weight of the body is coming downward. So we say acceleration is also in the direction of G. So we say acceleration is also positive. So students should be very, very careful about acceleration and acceleration due to gravity. In the case of acceleration due to gravity, that is, we are talking about body that is moving under the influence of Earth gravity. So we must always consider that we can actually have different cases. Maybe we can simply talk about that. I know most of this has been taken in our early classes. Now, what I'm saying is that if we take the first case now, let us consider a situation whereby we take a downward direction to be positive. Downward. So now, so far we are taking G towards downward direction because gravity is always acting in the direction of what? Of the weight of the body. So the body, as you can see from here, is also coming downward. So we say acceleration is also equal to the positive G direction. So in that case, so far we are actually considering motion under gravity, and again we are considering what we call a straight line motion or rectilinear motion, which also called motion in one dimension. So we say the acceleration of the body is acting in the same direction as our gravity. So in this case, we consider all our speed equation as we have discussed under accelerated body. And what we take now is that we take A to be equals to positive G. And another thing we also put in consideration is the body is not moving at a distance. In this case, it is moving at an height. So we also consider the distance of the body to be the same thing as capital letter H, or if you like, you know, use small letter. So all the speed equation we have learned before, which are V is equals to U, we have plus GT. We can see that the A I'm turning to G. The second case, we have V squared is equals to U squared plus 2GH. The third case, which we can discuss about H equals to UT plus half GT squared. And the last case, when we talk about the height at the time of 1, we say U plus V divided by 2 multiplied by T. So these are the speed equations that we discussed about accelerated body. And in terms of gravity, or what we call free-form motion, we consider downward direction as positive. And the second consideration is the upward direction. So if we also take upward direction as positive, upward direction, in this case, if we say G is also positive in upward direction. Now, if you look at the direction, look at this. Let me give you a simple illustration here for understanding sake of concept. Now, in this case, if you were there is a graph, body is going up. Now, we say G is positive. Now, you can say G is positive in the direction. This should be the direction of the body. So, acceleration of the body is going against the direction of the gravity, which we said is acting downward. So because it is not acting in the same direction, we say the acceleration of the body, because the body is being thrown off, is going to be a negative of gravity. So in this case, when we say G is what? Is positive in upward direction, what we are trying to say is that the acceleration will be negative of G, because acceleration of what? Of the body is moving in opposite direction. So always keep it in mind that acceleration is negative of the gravity when body is moving upward. And all these remain constant except that the sign is going to change. So all our speed equation will now turn to V is equals to U minus GT. The second equation will be V squared is equals to U squared minus 2GH. The third equation will be H equals to UT minus half GT squared. And the last one will be H equals to U minus V by 2 multiplied by 2. So students should keep this in mind in terms of numericals and applications. Now, to further understand the concept, another important formula, let us take one example before we talk about the synonyms. Now, about the examples we are going to look, let's take this simple illustration. Now, a body threw, or a boy threw a ball throws a ball up at a speed u meters per second. The question is find A, we have the time to reach the maximum height. Time taken to reach the maximum height. And the second part of the question says the maximum height attained, by the ball. So this is the quick one we want to quickly look at here. And from what I've talked about, let us take a realistic explanation to understand the movement of the motion of the ball. Now, the ball here is on ground. Diagram not drawn to scale, please. Now, throws, let's say this is the boy. For understanding's sake, we are trying to draw a realistic example. Now, the boy is throwing an object upward, or a ball which was thrown up. Let's say the ball was thrown up to a particular point, as you can see. Now, at the point where the ball was thrown up, the ball is going to reach a maximum, and we are told the ball was thrown up at an initial speed of u meters per second, u meters per second as this. Now, the ball is going to reach a particular height, or it's going to reach its final velocity at the top. So we can say the final velocity I will call F for understanding's sake. Whenever a body is thrown up, the final velocity of the body is going to be 0 meters per second. So please keep that in mind. So as the ball is being thrown up, initially the ball was thrown up at an initial time of t is equals to 0, which we don't know. So we say it is at rest. With initial speed of u meters per second, it reaches a height, which we don't also know. We can call the height h for understanding's sake as well, to understand the physical illustration of how to get speed equations and some other formula that is important in solving questions. So, and you should also know that when the ball is thrown up, it will be retarded from my explanation here by gravity before we called you, because it's going against gravity from explanation. So at this point, we should also keep in mind that the ball reaches here, it doesn't stop there. The ball will also come back to where it was being thrown. So that is another thing we are going to consider. Now, to solve the first question, which says the time to reach the maximum height, we can simply use the speed equation we have discussed here, because the ball is going against gravity. We have V is equals to U minus GT. So from direct substitution, we are looking for the time. The final velocity we call VF, which is 0, is equals to initial speed was also 0. As we already discussed, okay, we are looking for initial speed. It was also, let's take it, we are taking initial speed in the question as u minus g multiplied by the time initially was taken. We are looking for the time to reach the final distance. We can take the time to be t final for understanding's sake. So if we say this is t final, Then from subject of formula and relationship, if we make C final subject of formula, it will give us nothing but what? U divided by G. So that is the first one, and that is the solution to the first question. About the second one, the examiner asked us to look for the maximum height. When the ball was thrown up, it reaches a particular height, which is the maximum height. Also from our speed equation, which we have here, we can as well solve that one by saying the second equation is v squared is equals to u squared minus 2dh. As discussed that the body was thrown up, it reaches a final velocity of 0 meters per second retarded by g. We can therefore say the 0 squared is 0 is equals to initial speed is u squared minus 2 into bracket. Remember, this is g, and the height is what we are looking for in this case. We call h. So here, making h subject of formula, as you can see, h maximum, or the maximum height the body will reach, is nothing but u squared divided by 2g. So now, students should be very, very careful and keep these two formulas in mind when they are dealing with what numerical, because this formula of time, it will take a body to reach the maximum height, should be kept in mind, because we are going to use the direct formula in some numerical application as we move forward under the topics of motion in 1D and motion in 2 dimension, as well as the maximum height of an object. A direct formula of u squared is equals to 2d. It's also important to keep in mind. And also, finally, before I call it a day on this one, now when the body reaches up, I said it will not stay up, it will also come down. So we can also say the time it takes the body to go up and come down to its initial position, which we call the time of flight, is double the rate of the time in which it is taking to reach the maximum. What? The maximum. So the time of flight, which we call the time it takes the body to go up and come down, can be equals to what? 2 times of the time it takes to take what to get to the what to this point. So we say 2 u divided by g. So students should keep this formula in mind and bear it in mind that we are going to be using it in other applications of solving numerical questions. So this is where we are going to